Hello, good evening to all of you. I am here to discuss about the concept of centripetal acceleration and tangential acceleration. And here I am Atiqur and pursuing MTech from IITJEE. Let's start the concept of centripetal acceleration and tangential acceleration. First of all, is it necessary if any particle performs a circular motion? Is it necessary that particle must be have a tangential acceleration, or is it necessary that particle must be have a centripetal acceleration? If not, why? If yes, why? Means in a physics, everyone must be asked a question: why it is so, why, how, why, what. Let's discuss about this concept. First of all, we know some few concept before discussing about this concept. The first is prerequisites. First is when line 1 is perpendicular to line 2, line 1 is perpendicular to line 2, and line 3 is perpendicular to line 4, line 3 is perpendicular to line 4. The angle between 1 and 3, must be same as the angle between 3 and 4. How it is so? It's so easy. If this angle is 90 and this angle is theta, it must be a 90 minus theta. And this angle is 90 degree, then it must be a theta. Then this sum of angles 90 minus theta plus 90 plus this question mark must be a 180 degree. That this question mark is nothing, it is same as theta. We use this concept. And the second one is triangle law of addition. बहुत ध्यान से समझियो. Triangle's law of addition. Triangle law of additions. Here, let us suppose we have one vector and we have a two vector, and what I want to find the resultant of these two vectors. The resultant vectors must start from the tail of first vector and the head of resultant vector and the head of second vector must coincide with each other. Let us name them. This is A and this is B vector, and this is nothing, it is a resultant vector R. This resultant vector is nothing, R vector is equal to A vector plus B vector. Vectors can't be added like a scalar. By using these two concepts, we derive all this formula. Let us suppose a particle performed a non-uniform circular motion. Non-uniform circular motion. That's not a good circle. Let's draw some perfect circle. Here is some perfect circle. Must be. This is center O. We know that every point on the circumference of circle must be at same distance from the center O. Suppose this distance R. This particle has a velocity v. Here, and this particle perform a non-uniform circular motion, means its magnitude of velocity varying at each and every point. Let's by when angle theta, suppose this angle is very small, let's call as d theta. If this particle reach to this position, then its magnitude of velocity increases from v to v plus something called dv. dv is nothing, it is a differential change in velocity. Oh, then is it necessary a tangential acceleration exists? Is it necessary that centripetal acceleration exists? If exists, what will be the result? Let's let's focus here. All of you please concentrate here. All of you please concentrate here. Suppose we have this O point is here. Its velocity is v. And suppose this velocity is v, and this particle has velocity v plus dv. This particle has some incremental change in velocity, that is v plus dv. This is line 1 and line 2. Line 1 is perpendicular to line 2 and line 3 is perpendicular to line 4. The angle between 1 and 3, we already know that. That angle is d theta. Means the angle between 1 and 3 must be same as the angle between 2 and 4. Means the angle between v and v plus dv is nothing. It is the angle. When we join this v and the v plus dv vector, then the angle must form. The angle must form is d theta. Let's elaborate. Suppose this is v here, and this vector is v plus dv. That has a two vector. Means this vector is nothing. It is a dv. This vector is nothing. It is a dv. Means change in the velocity dv. We have this angle is d theta. We have to make component dv. dv has two components. One is along the direction of v, and another one is perpendicular to the direction of v, which the component which is along the direction of v is nothing. It is a tangential direction of velocity v, and the component of dv which is perpendicular to the v is nothing. It is towards the radial direction. It is nothing. It is towards the normal direction. Let's component it. This is dv, and this is along the direction of tangential direction. This is dvt, and this is along the direction of along the radial direction. This is known by the name dvn. We have, बहुत ध्यान से समझियो. First of all, please focus here. Man. First of all, please focus here. This is nothing. This is a tangential direction. This is nothing. This is a tangential direction, and this is a normal direction. If I want to find that acceleration in tangential direction acceleration means change in velocity in the tangential direction divided by time. Means tangential acceleration means at is nothing. It is dvt divided by dt. Hey. All of you know now how to make a component of velocity, how to make component of any vector quantity. Let's suppose we have a vector a. We have to make a component in the x direction, and we have to make a component in y direction. Those component is always perpendicular to each other. Let's name this angle is theta. This two component. This component is ax and this component is ay. The theta which is attached to a component a cos theta, and the theta which is perpendicular to the theta which is not attached to that component, it comes to be a sin theta. Let's dvt. What is the value of dvt? Dvt value means we have two component v plus dv cos d theta. Means we have two component v plus dv. Means let us suppose this is v plus dv, and this is d theta, and this whole is v plus dv cos d theta, and perpendicular component is v plus dv sin d theta. everyone must be know through it. V plus dv has two components. One is along the tangential direction and one is perpendicular to the radial direction, which is perpendicular to the normal direction. If theta is very small, if theta is very small, then cos d theta is equal to 1, and sin d theta is nothing, it is a d theta. How we get it? How to know? We go to the chapter in maths called limits and derivative, where we can expand the expansion of cos x, and we can do the expansion of sin x. By using these things, the value of cos d theta, and d theta is small, the value comes out to be a 1 and the value comes out to be a 2. dvt, what is the value of dvt? dvt means whole things minus v, मतलब v plus dv cos d theta minus v, it comes out to be a dvt. It comes out to be a means v plus dv cos d theta minus v divided by dt. And cos d theta is very small, then cos d theta is equal to 1, then it becomes v plus dv minus v divided by dt. V minus v is 0, it becomes dv by dt, and we already know that tangential acceleration is nothing, it is a dv by dt. Oh my god, if tangential acceleration is nothing, it is a change in the magnitude of the velocity with respect to time. With respect to time. If in a uniform circular motion, the magnitude of velocity that a particle performing a uniform circular motion does not changes its velocity, means dv is constant, its v is constant, then its differentiation is 0, then tangential acceleration is 0 in a uniform circular motion case. But in a non-uniform circular motion case, that v is not constant, then if v is not constant, then tangential acceleration must exist. Tangential acceleration arises due to change in the magnitude of velocity. I think this is clear. I think this is clear right now. Let's focus on centripetal acceleration. Centripetal acceleration means that is a normal acceleration. Normal acceleration means change in velocity in the normal direction with respect to time, means dvn by dt. What is the value of dvn? dvn means nothing, it is v plus dv sin d theta, v plus dv sin d theta divided by dt. And we know that sin d theta is very small. Theta is very small, that d theta become sin d theta become d theta. This will become v plus dv d theta divided by dt, and normal acceleration is equal to v plus v d theta plus dv d theta divided by dt. And we know that this is a very small quantity v, and this is a very differential change in the angular position of the particle, and this is the small change in velocity, magnitude of velocity in the particle, that is very small, that is tending to be 0. It's tending to be a 0. Then normal acceleration is nothing, it is a v d theta by dt, and by using this we know that this particle, when this particle reaches from A to B, it covers some distance ds, and its r is constant. We know that delta is equal to r by radius, delta is equal to ds by r, then we can write v into delta is equal to means ds by r into delta, What is this ds by dt? What is this ds by dt? ds by dt is nothing, it is a tangential velocity. ds by dt is nothing, it is a tangential velocity. ds by dt means v. ds by dt means v. N is equal to v square by r. I think so. This is the first time you know how to prove this. Normal acceleration is equal to v square by r. Normal acceleration is equal to v square by r and n is equal to v square by r. If particle performing a uniform circular motion and if particle performing a non-uniform circular motion, normal acceleration is nothing a change in magnitude of velocity, means velocity must be exist, means n is equal to v square by r. If v exists means normal acceleration exists. Normal acceleration means centripetal acceleration must exist. It means that if a particle perform a uniform or non-uniform, centripetal acceleration must be there. Centripetal acceleration must be there, always kept in mind. But tangential acceleration in a uniform circular motion is 0 and in non-uniform circular motion it must be 0. Tangential acceleration arises due to change in the magnitude of velocity and normal acceleration arises due to change in the direction of velocity. Let's conclude here. Let's conclude here, man. Let's conclude here. In uniform circular motion and in non-uniform circular motion, if we talk about tangential acceleration, means AT. Uniform circular acceleration means it must be 0 and it must not be a 0. And normal acceleration must be there, not is equal to 0, and normal acceleration must not is equal to 0. Not is equal to 0. What is the formula of tangential acceleration? Means tangential acceleration is nothing, it is a rate of change in magnitude of velocity, and normal acceleration is nothing, it is v square by r. So tangential acceleration arises due to change in magnitude of velocity. And normal acceleration arises due to change in direction of velocity. I think so it is clear to all of you. So thank you so very much, and I will discuss about some next variety topic. Thank you so very much.